Artificial intelligence is everywhere. It helps doctors detect diseases earlier, recommends the perfect movie, manages traffic in busy cities, and even supports disaster response. AI can analyze millions of data points in seconds, something no human could ever do. But that's exactly where the complexity begins. AI doesn't just assist anymore. It observes, evaluates, predicts, and sometimes even decides. And when systems begin to influence who gets hired, who gets a loan, or who gets flagged in public spaces, we have to look more closely at what's happening behind the scenes. Most problems with AI don't start with bad intentions. They start with data. AI systems learn from historical information. They look at patterns in past decisions and try to replicate what appears to work. The issue is simple. History is not neutral. It reflects inequalities, imbalances, and sometimes discrimination. If an AI system is trained on that history, it learns those patterns as if they were correct. Take hiring as an example. Imagine a company where most tech employees over the last decade were men. An AI trained on those past hiring decisions might learn to associate certain profiles, certain universities, hobbies, even writing styles, with successful candidates. Even if gender is never directly entered, the system can pick up indirect signals. In a simplified scenario, 70% of male applicants might be rated as high potential, while only 50% of equally qualified female applicants receive that rating. The difference seems small at first glance, but across thousands of applications, it quietly reshapes opportunity. The same dynamic appears in lending. If certain neighborhoods historically received fewer loans, an AI trained on that data may continue the pattern. Two applicants with identical financial profiles could face different outcomes simply because of geographic patterns embedded in the training data. The system isn't trying to discriminate, it is simply scaling past patterns. And that is exactly why bias in AI is so difficult to detect. It looks mathematical and therefore objective. But math applied to biased data doesn't become fair. It becomes automated inequality. Bias becomes even more serious when AI leaves the digital space and enters physical environments. Facial recognition technology is a strong example. These systems analyze facial features and compare them to databases in real time. They can scan thousands of faces per hour in public areas. Supporters argue they help find missing persons or prevent crime. The challenge is that accuracy is not evenly distributed. In simplified terms, a system might correctly identify 95% of lighter-skinned men, but only 70% of darker-skinned women. That difference translates into more false matches for some groups than others. A false recommendation for a movie is harmless. A false identification in a police database is not. Even a small error rate becomes significant when applied to entire cities. This connects directly to predictive policing. These systems analyze past crime data to forecast where crime is likely to occur next. On the surface, this seems efficient. Data-driven resource allocation sounds rational, but if certain neighborhoods were heavily policed in the past, they naturally produced more recorded crime data. More patrols lead to more recorded incidents. The AI then interprets that concentration of data as higher risk, which results in even more policing. Over time, this creates a feedback loop. Past enforcement patterns shape future enforcement decisions. What began as data analysis can slowly turn into structural over-surveillance of specific communities. The technology doesn't intend harm, but without careful oversight, it can amplify existing inequalities. There's another layer that often receives less attention. Who controls these systems? Advanced AI requires enormous datasets, computing power, and technical expertise. That means the most influential systems are typically built by large corporations or governments. When these entities use AI to rank employees, set insurance prices, determine creditworthiness, or analyze public behavior, the people affected rarely see how those decisions are made. This is sometimes called the black box problem. If you cannot understand why a decision was made, you cannot meaningfully challenge it. And if decisions can't be challenged, accountability becomes weaker. AI doesn't just optimize processes, it redistributes power. The solution is not to stop using AI. It is to design it carefully and govern it responsibly. Transparency is essential. When AI systems influence important outcomes, people deserve explanations in clear language. Data protection also plays a critical role. AI depends on personal information, financial records, location data, online behavior, sometimes even biometric data. Without strong safeguards, surveillance can quietly become normalized. Most importantly, human oversight must remain central. AI can analyze patterns and suggest decisions, but in high-stakes areas such as hiring, lending, healthcare, or law enforcement, accountable humans must remain involved. Automation should assist judgment, not replace it. Fairness also requires active testing before deployment. Systems must be evaluated across different demographic groups and adjusted where necessary. If two groups with identical qualifications produce very different outcomes, that imbalance must be examined and corrected. AI does not have values of its own. It reflects the values embedded in its data and its design. If society contains inequality, AI can amplify it. If society prioritizes fairness and accountability, AI can reinforce those principles instead. Technology is not destiny, it is direction. The real responsibility lies with developers, policymakers, companies, and citizens. AI is a tool, but tools shape the world in which we live. If you found this video interesting, check out the channel for more exciting videos about economic topics and stay updated. Next, Econary. Think wisely, evolve quickly, understand profoundly.